Greetings everyone, this is Mr. Mall. Today I'm doing a podcast on a conversion problem that involves units that have exponents such as cubic centimeters or square seconds, and also quantities that have multi-dimensions like miles per hour or meters per second. So I'm going to do a problem where I combine both of these together and see how we can use some of the strategies we've learned about in this class to do one of these like mega conversion problems. So let's go ahead and get started. So my problem says this. I have 17.5 cubic micrometers per nanoseconds, and I want to convert that to kiloliters per second. So this is probably someone's like measuring how long it takes for something's volume to change. It has kind of two dimensions at once. So I'd like you to think of these problems with multiple units like this as kind of two separate problems. You have kind of the top or the numerator and the bottom that are both happening at the same time. You're trying to do like two conversion problems at once. So what I might do is I might first off figure out, well, what's on the top, on the bottom. Let me rewrite this for you. 17.5 cubic micrometers. And on the bottom, there's always a 1 down there, but in this case, hanging on the bottom is also nanoseconds. So I want to keep that unit down there. So on the top, I have cubic micrometers, and I want to get all the way over to kiloliters. And then the bottom I have nanoseconds, and I want to convert that to seconds. Okay, I have kind of two problems going on at once, and that's fine. We can do that. Okay, so the first thing I need to do is I need to find a way to get from cubic micrometers all the way over to kiloliters. I need to ask myself, what kind of quantity are we talking about? So I have a little cubic micrometer. Someone had to take a length times a width times a height. This is a measure of linear volume. If I look at kiloliters, this is a measure of liquid volume. So I need to find a converter between linear volume and liquid volume, and there is one. This would be a good one to memorize. 1 cubic centimeter is equal to 1 milliliter. Okay, that's how we would go between those. Conversely, you could also say 100 centimeters cubed. Cubic centimeters is 1 liter. Now you could use either ones in this problem. I'm going to use the first one. It's a little bit more complicated, but that's okay. I want to show you the process. So what I can do then is I can go from cubic micrometers. I want to get over to liters. I want to get out of this linear volume. So I would go from cubic micrometers to cubic centimeters. Once I get to there, I can go to milliliters, and then we could go to kiloliters. Okay, I need that same base. Nanoseconds to seconds is really nice. That's going to be a one-step conversion. Both have the same base unit, so we can just go using our metric prefixes. So I have two problems at once. Okay, so I'm going to need some conversion factors here for sure. So we need to figure out the first step, micrometers, cubic micrometers to cubic centimeters. So I need to take and I need to look at those units. I want to go from cubic micrometers over to cubic centimeters. Okay, so the first thing we need to do, now we're dealing with these cubic units, so we need to be careful because we can't just blindly say, oh, powers of 10. Okay, so micro is 10 to the minus 6. Centi, I look at that table, is 10 to the minus 2. And just go from here because these cubic units means we need to do something else with it. So what are we going to do? Well, I'm going to do the shortcut way because I like it. Okay. I take the first power of 10 and I subtract the second power of 10 to find the step difference between these two prefixes, micro and centi, and I'm going to get a value of -4th. So 4 powers of 10 difference. So I look at I'm going to draw a new conversion factor. 1 micrometer is equal to 1 times 10 to the -4th centimeters. Now the question you have to ask yourself, are these two things the same? Cubic micrometers and micrometers? Well, the answer is no. We're talking about completely different dimensions, linear versus three-dimensional shape. So what we need to do is we need to take all of this and we need to get those units cubed. So we're just going to cube everything. Okay, we're going to be fair, we're going to cube everything. And when I do that, I'm left with 1 cubic micrometer is equal to 1 times 10 to the, remember when we have exponents raised to another exponent, it's not add them, now it's actually multiply them. So -4 times 3 is -12, and my unit gets squared as well. Okay. So now I have this new converter, which I can go and plug back into my first conversion factor to get me that first step. Okay. So we're going to go ahead and do that now. So I'm going to go 1 cubic micrometer is equal to 1 times 10 to the negative 12th cubic centimeters. All right. First conversion's done. Awesome. The next one, we're going to use our little conversion factor we came up with over here to get from linear volume to liquid volume. So I'm going to go ahead and do that now. Okay, for every, let the units be my guide. For every 1 cubic centimeter, that's 1 milliliter. It's the nicest conversion factor you ever use. So now I am out of centimeters cubed. Now I want to look at going from milliliters to kiloliters. Okay, so now I'm going to look at my milliliters to kiloliters. Now thankfully, these are not cubic units, so we don't need to worry about the squaring or the cubing or anything. But I am going to look at the powers of 10. Okay, so milli is 10 to the minus third. Kilo is 10 to the third. So I can find the step difference between them. Negative 3 minus 3 gives me negative 6. Okay, there's 10 powers of 6 difference. So what I can do is I can make a new conversion factor. 1 milliliter is equal to 1 times 10 to the negative 6th kiloliters. Okay, there's my new converter. Okay, so I'm going to go ahead and use that and plug it back in up here to get me from my milliliters to kiloliters. So I'm going to do that now. 1 milliliter, I canceled that out too early, is equal to 1 times 10 to the negative 6 kiloliters. Beautiful. Okay, we're almost there. The top is done. All the units on the top have reduced down to kiloliters, which is what I want. So now I need to look at the bottom. On the bottom is nanoseconds, and I need seconds on the bottom. So I actually have to do one more conversion factor to get those units to work out for me. So now I'm going to look at the difference between nano and seconds. Nanoseconds to seconds. Nanoseconds. Nano means 10 to the minus 9th. Seconds, if you wanted to think of it as 10 to the 0, you totally could. So 10 to the 0. So I could do the same thing. Negative 9 minus 0. Okay, it's going to equal negative 9. So 1 nanosecond is equal to 1 times 10 to the negative 9th seconds. A really cool thing you can do here is you can think of nano means 10 to the minus 9. So 1 nanosecond is equal to 1 nanosecond. Okay, those are equal. You can think of it like that. So I'm going to do my last conversion here. Get my nanoseconds all the way over here on the left side to cancel. So 1 times 1 nanosecond is equal to 1 times 10 to the negative 9th seconds. My nanoseconds cancel all the way over there, and I'm left with seconds on the bottom. So I'm going to go ahead and punch all this in. Now what you may want to do is, you may want to punch all this in your calculator, but you really don't need to, because we're dealing with all of these powers of 10. So what you may want to do is you could go ahead and look at your powers of 10. I have negative 12 on the top, negative 6. We could add those together. That's 10 to the negative 18th. And then I have negative 9 on the bottom, so I would subtract those on the bottom. So we have negative 18 minus a negative 9. We're going to get a power of 10 to the negative 9 left over. So 17.5 times 10 to the negative 9th. Okay, and that's going to be our units left over are kiloliters. Before I write my unit, am I done? No, I got to put this in scientific notation. So what I'm going to do is I'm going to move this decimal back, make this number smaller, which makes my power of 10 bigger. We're going to go 1.75 times 10 to the negative 8. I got 1 power of 10 smaller, so it's going to get 1 power of 10 bigger. And then my final units left on there are going to be kiloliters per second. I know this is jammed in here. I'm sure you guys can read that okay. Okay. So my final answer, 1.75 times 10 to the negative 8 kiloliters per second. I apologize for the noise out here, but hopefully you were able to follow that, and I hope that it was helpful.